Hey, how's it going? My name's Justin. I'm the newest SRE here at Emojit. Whatever. I joined this company recently, and I wanted to record my onboarding experience because the other people told me there's no docs. So I'm just going to go ahead and record it as I go through things and as I learn things, and hopefully that's going to help whoever comes next. So if you're watching this right now, welcome to the team, and I hope these docs help you out with whatever it is we're trying to do. So yeah, well, let's just go through it as let's record maybe my first week or so.
Justin, go ahead.
Yeah, yesterday I was just getting familiar with the code base and started writing some docs.
Jacob, you got anything? Not from my end.
It's my
just
coworker.
looking at the deployment, seeing
We're
how
in
we
a
can
stand-up,
fix it.
so we'll get
Okay,
back
I
to
think
just
that's
a
it,
minute.
everyone. Have a good day.
Yep. Okay. Thanks. Bye. You know, I had this thought. Why do they call it SRE, Site Reliability Engineering, and not availability? Like, why do we keep talking about reliability? What is reliability versus availability? Like, availability is what we typically build. Like, that's how we build things. Load balancers and replicas and all those are all availability pieces. But I guess reliability is more like, is it correct? Is the thing that a customer requests, are they getting what they expected? That's reliability, right? It builds trust. Availability is part of that. But reliability is really about making sure the thing that they get to the customer interaction is reliable. And in our case, for we want to serve up those emoji as fast and accurately as possible. We want to make sure everyone gets the right emoji. And you know, I guess when I really think about it, like site availability engineer, it doesn't really make sense as much. Like an SAE, and even like highly available, HA, like what do we call it? HR? Should we actually be going for highly reliable? I don't know. And when we measure availability, we're measuring it in number of nines, percentage available, 99%. But do we actually measure reliability with that? Maybe we should be. Maybe the better metric is how reliable are you, not how available you are. And if you're 99, if you have 5 nines available and you're only 1 9 reliable, you're kind of not there. Okay, so it's only my second day, but I understand a little bit about our service that we offer, right? Emoji, so it's emoji.it, I finally realized. So it's Emojit is the company, and here's our main API up here, okay? And customers come and they request emoji from us through our I think it's GraphQL, but it might be something. It might just be RPC. I don't know. But there's an API here, and that's what we're serving them out from. And down here is our emoji layer. This is our serving area, our back end. And someone said we needed microservices, and so each one of these, we split up all of the emoji into their own microservice. So every emoji gets separate balance. So high availability is we spread them out, and then we can individually scale the emoji that are more popular. And so I think the poop emoji is pretty popular. So there might be like 10 replicas of poop. Smiley is pretty consistent. That's like a 15. Everyone loves a good smiley. The frowny over here, I don't know. But they all come back to this database where we actually get the emoji from. We store them all back here. I don't know if this is highly available. I don't know if I requested some poop and that doesn't, if it doesn't get from a read replica properly, I don't know back here, the database reliability side of it. But that's probably a separate team. I'm the site reliability, so I'm just focusing up here on the API and a little bit down here of how it interacts. But the database, I don't know yet. But I just wanted to give, for anyone onboarding, this is our rough architecture. Microservices, one for every emoji, database, and the API where people are requesting. I don't know how this runs yet.
Happening. Did you try restarting it? And
Hey,
it didn't come up.
you're on mute. Don't worry.
What are we looking at next?
It's day 3. Welcome back.
does it show on the log?
I know you didn't go anywhere, but I did. And so
No
It's
error
day 3.
messages?
They gave me a pager,
Okay, so
or not a
would
physical
debugging
pager. That's
mode work?
ridiculous.
Is there
I'm
something
on
else? Is the
pager
outage
duty
not
now,
start
so
at
I got
all?
paged for this outage, and so we're on the bridge right now.
Okay,
so
so where did we hear
something
about the
happened.
problem?
I don't know what, but the site's down,
Okay,
and so we're not
so
serving any emoji. So
it was
I'm
on
just
Twitter?
trying to
People, the
watch and
customers on
learn.
Twitter were just
Maybe we'll learn something too as we go through it.
and where else are we? Is it only in one place?
Did anyone update the status page?
Oh no! Oh, someone can someone do that? We can't right now because it actually is published on us.
Apparently,
No, that's
apparently the
not,
status page is kind of a touchy
it's not
subject.
going to work because they use us.
Oh,
Yeah, all their emoji are served from our service. We can't. There's
the status
so
page.
We have to bring up our service.
We
to
host it
to
somewhere
let
else, like
them
another
show
third
the
party
status?
runs our status
Yeah,
page for
that's
us.
it. That's pretty much what we
But
have
they
to do.
use us
Okay.
for status,
What?
for getting emoji
Okay,
for
so
their
where
page.
are we at?
So we can't.
We tried restarting it.
We
right?
can't update the status page.
And that didn't work.
Okay.
Okay. Did we roll back the code?
So they're down too.
No. Okay. Yeah.
Cool.
So we reverted it.
We're gonna fix this. We'll get
and-
back.
And it's still not running. Okay. So what do the logs actually say?
Hey, so the outage is over. We got it figured out, and I learned some new things that I wanted to tell you about too, about the architecture. So the first thing I learned was about the database. I thought this was, maybe highly available or whatever, but so this is actually it's actually S3. It's just a bucket, and the bucket fuse mounts. Uses libfuse into all the containers here, and I found out here. So this whole section here, the whole middle tier, at least this is all Kubernetes. This is all running in Kubernetes. Haven't quite figured out that piece yet, but so S3 is our database. And we serve all of our pods, each emoji in its own microservice inside of Kubernetes. And I think they mentioned that the API was ingress. I'm still not too sure on that. And so the actual outage was happening with the mount points. The pods were losing their mounts, and I don't know exactly why yet, but we did get it fixed. One of the senior engineers said he knew the problem. He upgraded or updated something or changed a config, and now everything was starting to create again, and the emojis were created. Again, the hosting service that uses, I found out that a lot of people use us. Like I thought this job was going to be kind of chill. We just serve emoji, like that's it. I did not realize that emoji was big business, and actually very critical service. And so we were down for about 30 minutes, and we lost at least 1.9 for the month, and that's going to directly impact revenue. And so I don't know how to make this more highly available, but we're going to keep researching, okay? And we'll make some docs for it. So, but yeah, we figured out that much right now. So we got Kubernetes here. Kind of a Kubernetes logo, and S3 database, which generally is highly available, so that's good. It's highly available to us as a service, but we need to mount it properly. So let's dig into it some more.
Go with multi-cloud. Multi-cloud, I think, is the only solution for us
okay.
long term.
Okay, yeah, I'll look into it. Thanks. Bye.
All right, great.
Ugh. Okay. So the outage the other day caused more trouble than I expected, and not only do we need to make sure we have better reliability. Availability doesn't actually matter, but now our VP says we need to go multi-cloud. So yeah, the engineer. There's only 3 of us. But apparently this is a thing, so we have to figure out how to get more reliability from the system, and the VP says that's multi-cloud. He probably went to too many airports and saw too many ads, but we're going to figure it out, and we're going to figure out how to implement something that's more reliable in its current form. So well, let's go figure it out. Oh my gosh, oh my gosh, oh my gosh, oh my gosh, oh my gosh. Oh. Remember how I told you we deploy a microservice for every emoji? Do you know how many emoji there are? There's a lot. There's a lot more emoji than I thought. Oh boy. Okay, wait. Let me show you this. Okay, so all of those emoji, if we look at our deployments, well, first of all, oh my gosh, these are just in one namespace. Like everything's deployed to default. I don't know what to say about that, but let's go beyond that and just look at our deployments. How many deployments do we have? We have 1,600 deployments. That's so many emoji. Why? Okay, so I can't even, like all of these pods, I don't know. We found out some of the problems, and 9,000. We're just scaling this. This is wrong. This is probably wrong. We have a lot of them working. Okay, a lot of it, we found out in this outage that it's actually just some of these more obscure, the more obscure emoji. These are the ones that are failing. So if we look at any of them, okay, and here we go. This is failing to create the sandbox. Something about failed to assign an IP address. Cool. So we dug into that a little bit more. Okay, so we know there was something with storage, and we found out something with IP addresses. But that's okay. Like are these failing all the time? Let's just, oh my gosh. All right. The other thing that I noticed is if we look at the actual usage. None of these services, none of these nodes are being used at all. If we're lucky, it's double digits, like in the double digits. 20 is about the most I see. 1%. Okay, we need to clean this up real bad. And so let's figure out how we can make this a little more stable. All right, so the other thing that I noticed here is we're not running highly available like I expected. If we look at the zone on the output and then sort by zone, we have one node in 2C. The vast majority is 2B, and then we have some 2A. Yeah, that's what I expected. 75 in 2B and 37 in 2A. So we're not spreading out this workload at all. I know we're looking at availability still, but availability is a prerequisite for reliability. So let's tackle that job first. All right, surprise, surprise, this is all a lie. It kind of works this way, but let me show you what I just found out about the app, okay? So all of these pods with the different deployments for each emoji, yeah, it's actually one app, okay? So here, let's just erase all of this here. Okay, we still have our S3 buckets. We still do have a deployment per emoji, but the app is one app, okay? And the app only reads emoji.png, and it reads it from slash, just on disk. Every single one of them reads the same file, and that's what gets mounted here, okay? So in order to save on application simplicity, we put all of our complexity into the infrastructure. Sometimes that's okay. Complexity has to exist somewhere. It has to exist somewhere for a complex application. You can't just hide it. But did we want to put it in the app, or do we want to put it in the infrastructure? And so in the infrastructure side of things, we have to have separate ingress rules with separate deployments, with separate mounts to S3 to mount the same file. And now this same file, so it doesn't matter if it's poop here, it gets rewritten as emoji PNG here. So half the deployment is the same. The container is the same, and the image name is the same, and what it serves is the same. But the API up here, when someone calls poop, That's what routes them through ingress, through that path to the right pod. And then we just did that 1,500 times for every emoji because the devs didn't know all the emoji that could exist. So let's look at the infrastructure first. Let's look at how we can simplify some of this infrastructure to make it more reliable on availability, right? Like we just need to make it more available. We also found out, because we had so many of these applications and so many pods, we were running out of IP addresses. Like there's a consumable in this VPC, the whole thing, that is IP addresses. We can add more compute as much as we want, but the VPC IP addresses were limiting us. And turns out running 10,000 pods isn't the best option to save some simplicity here in the app. So let's see how we can work together with the dev team and ask them what we can do. Okay, so we talked to the dev team, told them about what's happening and maybe how we can fix it. And they said they could address some of our issues. It's going to take them maybe a month or more to really address it, to make sure that it's stable. So we have two things we need to figure out right now. One is figure out how to get some of our services to start. They're still not running. And two, we also now are tasked to take on ownership of our own status page, which still means multi-cloud for my VP. So we got to look at what that means and maybe how we can solve that problem. So let's look at the first thing. We just need the application to run. We just need the services to be more stable, and we're going to need to simplify some of this complexity in the infrastructure. Let's get the IP address issue fixed, add some more IP addresses to our cluster, and then just make sure that the app's a little more stable. I'll show you how we're going to address that in the configuration, because that's the only thing that I have control over is the YAML that we're deploying. Okay, so here's what we're going to do. Just to start, I checked out all of my VPCs, and I have enough IP addresses. All of them have over 8,000 IP addresses left. We're using the right size network for this for 10,000 pods. We should be okay. So what I'm actually just going to do first is I'm just going to make them spread. Okay, I'm going to define how many of these pods or how many max difference I should have per zone and per machine. And so I have a topology spread based on a host name and the zone, and I want them evenly spread. So we just get more availability. Again, we're not looking at reliability yet. I have to build up to that. So availability, let's just go ahead and spread out all of our workloads. Okay, as these workloads are rolling out, I have a lot pending here and a decent amount running, but we're still not all the way up to where we should be. And what I'm noticing here is some of my smaller instances, my larges, have, obviously not very many pods on them because they don't need that many, but my 4XLs have a lot. So they have 200 easily. And so I'm bound here, I think, based on just the IP addresses I could have per node in that case. And so, like I said, 58 on these extra larges. I got to find where the ones that aren't running, why they're not running and what they're bound to. But we're going to go ahead and get all these nodes, all these pods to replace first, and then we're going to roll out and figure out what the next step is and which pods are left with not getting IP addresses or not running. All right, the more I dig into this problem, the more I'm realizing this is actually a bigger problem than I expected. So we already started to deploy out our pods and they're spreading across different nodes. But now here's two things that I found that were missing. The first thing here was we had no pod disruption budgets. Pod disruption budgets just protect the pods from all going away at once. And this didn't exist, and we want to make sure as we're rolling out these changes, we have at least one of each emoji service running. So we're going to make it HA, and hopefully that's going to deploy. But the other thing that we are running up against here is in our deployments here, In our deployment templates, we didn't have, all we had was one label, and the label was for each service, or for each deployment. And so we need to add this new make it HA label, but these match labels are immutable. So in order to roll this out, we have to delete the old deployment and deploy the new one. That's not a huge problem. We can go ahead and do that, and hopefully we can do it safely enough by creating new deployments. The last thing that we're actually doing here is on our provisioner, because again, I said that carpenters deploying our nodes, and we found that there's a lot of these smaller nodes in place, and we just don't want 2 core boxes. We don't have enough capacity to like have a bunch of 2 core boxes. It just makes too many IP addresses, too many overhead for daemon sets, everything like that. So we're going to go ahead and add one more restriction on what type of instances we get, where we don't want anything that has 8 cores or lower. So we have a greater than match on this instance CPU, and that's going to give us anything more than 8 CPUs. So as we roll out these changes, we're going to roll out pod disruption budgets, and we're also going to get 16 core or above instances, and that'll help us pack density there, but also fewer daemon sets, fewer kubelets, so less load on the API server in general. So let's go ahead and roll out these changes and see how it works. All right, one more thing that I noticed here is some of these systems with 64 CPUs are really big. And when I look at how many pods are running on each one, they're getting a lot of pods. We were down to 25 nodes for a second there, and we're shuffling them around. We had over 600. Some of them had 700 pods per node, and that blast radius is just too big. We don't really want that big of a blast radius if we lose one node. So one last thing we're going to try here is we're going to edit our provisioner, and we're going to set, we have this greater than 8 cores, but we're also going to say an upper bound of 64 cores, because I don't think I want a node that has that many pods on it, just for blast radius. And so we're going to go from, originally we had over 180 nodes, and without this upper bound, we went down to 25. Both of those numbers are kind of extreme for the size of our cluster, so we're going to go ahead and constrain it a little bit. So we'll get things that have 12 cores, 16 cores, 24, all of those things are great. We'll put them in the middle there, and these should end up with maybe a few hundred pods on it. Hey, so welcome to another day. That was a lot yesterday, and let's just go through it step by step, because I'm starting to realize some of the power of having these automated systems like Kubernetes handle that middle tier for us, because we redeployed over 10,000 pods multiple times yesterday, and we got all new systems. Like I said, we went from something like 180 nodes down to 25, and we ended up with something in the middle. And that would have taken a long time with any other system, with servers on a rack or with Terraform automating it. Those loops, the feedback loops we get from any of those other systems just takes longer. So by putting that complexity in the infrastructure was actually a good move for now to be able to figure out our high availability. And so the things we did, again, was we spread across, these are our pods. Originally, there was no constraint on them, and we were just using whatever the default was in Kubernetes. And the default happens to be to spread it okay. With Carpenter, it wasn't. And so our high availability wasn't there. And high availability isn't a spectator sport. You have to participate in high availability. You can't rely on the defaults forever, depending on how much availability you need. That's something I'm learning already. So by taking ownership of our availability, not only were we able to spread these across our nodes, but we also could spread them across regions as needed. And we could define how much spread we needed. And that was great, because now, in the case of a node going away, that pod isn't going to just randomly land anywhere. We know we still want availability over here in this zone. So in case this whole zone isn't available, our availability isn't flipping back and forth. It's not determined on when something's not available. We can control some of that stuff, and that is great. The other thing we did was we specified how big of nodes we wanted. We didn't say a maximum for our nodes just because we assume that they could fit and run. One last thing I did do yesterday was I actually set some resource requests and limits on them. I don't know. I have no idea. I didn't do any performance testing. I don't know what they're supposed to take. But I just kind of looked at what they were using with top and judging some stuff. I don't know if it was under load or not, but we're going to go ahead and figure that out. So I set a 250 M for the CPU and 64 megs for the memory as request. So that's the bare minimum I should get. By setting this, immediately all of my infrastructure scheduled differently. Everything started shifting around because this basis of how much memory and CPU I needed filled up these nodes by actually saying, hey, we need to reserve this space. And then I didn't have to worry about spikes. I can lower this later if this becomes a problem. But it was a great thing because you saw the pictures before. All of my CPU said 0. It was just 0 reserved. And that's not necessarily that's not predictable. And what I want out of this is I want a predictable system. I want to know when something fails, I can predictably get something else that'll replace it and be able to run the workload. The next thing I want to set up is I'm going to set up an autoscaler. So I can have the horizontal pod autoscaler. I want the horizontal pod autoscaler to create more or less replicas based on what they're using. So when someone requests Smiley, which is consistently, used, and poop, which are probably our two most popular emojis right now, those can scale up as needed. But honestly, like some of the flags, people don't really request them that much. There's a lot of alternates that people just don't need them. And again, with 1,800 or so emojis, we can drastically reduce or scale this out and figure out what we actually need and not just what we think might happen in the future. Predictable systems are reliable systems. And as I said before, complexity has to exist somewhere. It's going to be in the system, and the dev team's still working on reducing some of the deployment complexity. I don't need 1,800 deployments and ingress rules and volume mounts if we can put that in the code. And what I've learned by talking to them is because the complexity is going to exist somewhere, every system has complexity, you can hide it in different parts. You could put it in CI/CD and make it merge things. You can put it in the deployment scripts like we have right now, and that's helping us be flexible. But the thing that actually is probably best is putting the complexity in the thing that has the most flexibility. And right now our infrastructure is pretty flexible, but the application code is more flexible. And by putting some routes in the application code, that gives us a full programming language. I'm not trying to do it in YAML. I'm not trying to merge it together and make it do something that it maybe shouldn't with some label sets. I can just put it in the code, mount in the images together in one image, and we can get that all complexity in the application. And that's a great place to put it until it might become a burden. And so keeping with that, predictable systems are highly available. They're also highly reliable, because the reliability engineer in me says that I need to be able to rely on what's going to happen, and where the complexity exists depends on how I can make it reliable. So putting it in CI/CD is going to reduce errors going to production. But reliability in production really depends on how that complexity looks when it's running and how it's going to react to different changes in the environment. So we're going to go ahead and put in HPA, and we'll figure out how that scales and what it changes, and we'll look at that in just a minute. The last thing I'm trying to figure out here is this status page, because I told you my VP said we have to go multi-cloud for it, and I think he wants something that's not dependent on our existing infrastructure. If something goes down with our app, we need to be able to let customers know so that we can be honest with them. We can help them know that we're reliable, and we can track that reliability over time. So we need to put this somewhere else, and it might be no service provider, but the service provider, again, uses us to show the emojis on the page. So we might take ownership of that, and we're going to try to keep it as simple as possible to design it in a way that we can always update it. And that's the goal here, is make sure that that page is more nines than our application, because we need more nines here. If we don't need more nines, wherever we need the most availability, that might be a service provider, is probably fine. Do we need more nines than S3? I don't know. We'll figure that out. So we just got to figure out a good workflow and how we can update this and make sure that this is engineered so that it's available more than our actual application.
An email about the multi-cloud strategy that maybe we should think about?
Yeah, I mean, I guess I just think that maybe we shouldn't just go out and try to spread across multiple clouds and instead figure out what it is that we need for...
Well, the principal architect said this is the way we should do it.
Yeah, I know. It's going to add a lot more complexity, and complexity is the enemy of reliability. And my job is to make things reliable, and I want to help with that. I would like to. So can we just try to architect it this way, and we'll see.
Could you do it in a week?
Yeah, I think we can. I think we can make that work.
All right, you got 1 week.
Great. Cool. Thanks.
Bye.
Bye. Okay, so we convinced them to try something new. Instead of spreading ourselves across multiple clouds to avoid some theoretical outage scenario, we're just gonna focus on keeping it as simple as possible in an isolated environment. Because that availability that we might get is good enough for what we need, and we can do things with existing services that are outside of what we're doing for the application and the API to give us more nines. And even if we only get 4 nines from a provider, we can duplicate efforts in multiple ways to deploy it in multiple regions, to keep them isolated as cells, but still be available. And we get more nines because our availability of 4 nines in US East 1 doesn't necessarily overlap with availability in US West 2. And so if we can take that availability and add to it, then we can reduce the possibilities of it going down completely, because reliability isn't binary. This isn't an on or off. This isn't a, hey, available for who? Available where? We can balance that out, and we can spread it in areas that make it more available, even if 20%'s down or 50%'s down. That's still okay. That's not an outage because we can route traffic to another place. So reliability and availability isn't a 1 and a 0. Reliability and availability is all a lie. This isn't on or off. This isn't a light switch. Everything is failing all the time. All of these things are having problems, and systems that automate the recovery and routing around the problems makes it so that a customer still gets something they need. It gives them the right answer at the right time. So let's design the availability of our status page in a way that is simple, it's simple to update, and we can keep high availability and a lot of nines that make it reliable for customers without needing to go through too much engineering effort. Let's go to the whiteboard one more time. I think we figured out a couple things about this status page. So first of all, a lot of reading about how to handle failover and what you need for that. And there's this idea that Amazon has that's called static stability. And basically it boils down to the best thing to do in an outage is nothing. If you don't have to migrate workloads and you don't have to push things from one to another or flip a switch, disaster recovery never is. Like a DR strategy never really actually works out. And in an outage, you don't know what's not going to be available. So if you can add capacity and have stuff running that is already available to you, even with a site going down or even with an outage, that's the best situation to have more availability. In our case, for our status page, this is a static website. We don't need to update it all the time. It usually can just be cached. It can be somewhere else, and we're just going to go with the tried and true, throw it in an S3 bucket. And we have a region here and a region over here, and these buckets in both regions are going to do replication both ways. You can set that up. We have the buckets. We can handle that. If they don't actually replication, if this breaks for some reason, it's not actually a big deal. Developer laptop. Let's say we have an outage. We know the outage is happening. We're using Hugo to generate a static site. This is just going into the buckets. This command line and this laptop doesn't need anything. This is a Git repo. Any engineer can check it out and run this with the correct permissions to write. So in a case of an outage, we have a static file that generates our stats on if something's down. We can manually update this later. That's okay to be a manual process. Manual processes are typically one of the most reliable. If everyone agrees on what the process is, that's going to work. So engineer, in case of an outage, pushes and generates the site to whatever region they want. And we have a bunch of YAML configuration in there that says what's down or why it's down. But again, this isn't a binary thing, up or down. This is just to let customers know, hey, by the way, we know we're having some problems. There's also some options to put banners on the page, that stuff. But we're just going to push it to either bucket, and it'll replicate. We're going to front this with CloudFront, which is where our DNS points. Route 53 claims to have a 100% uptime. If you need more than 100% uptime, stop. Stop right now, whatever you're trying to do, okay? So CloudFront with Route 53 pointing to an endpoint. This points to a multi-access endpoint in S3. That allows us to expose both of these buckets at the same time. Active, active. We can route to both. We don't really care about latency in this case, but CloudFront's going to cache a few of those things. But it lets us set up this with our status page in the most simple and out of our existing infrastructure way. Because this is in multiple regions, because CloudFront is globally available, multi-access endpoints are globally available, none of these have a single region failure domain. And with cellular-based architecture, it doesn't matter if this entire region goes away, we can still route to this. That is okay to do, and status page can be updated from anywhere, at any time, as an engineer needs to push it. This is the simplest solution. We can do this side of it, we can own that, we can bake in all of the emoji we want here on our status page, and those are going to be compiled and pushed into the bucket directly. It's not pulling from our other assets. If we want to deploy those, whatever we can. This is how we're going to solve our status page problem, and let's go build it.
On again?
Yeah.
Yeah?
Okay.
Did we try get revert?
Hey, I'm
Okay,
really
what was the
sorry.
latest
I
change?
completely forgot to record. The
Did
last
you-
few
did you
weeks have
pull in
been
any new libraries?
crazy. But just FYI, status
does
page,
the server start,
amazing,
or is
right?
it
Like
just
that
crashing?
just worked. All of the other infrastructure changes
Okay,
we
you
made
checked the
have been
logs?
pretty stable. We just actually
about
rolled out the
in
new
a restart
changes
did-
for the application to
Okay.
remove the 1500,
So did we already roll
1800
back
deployments or
the
whatever.
change,
It
or
was
we
getting
were
out
waiting
of
for
control.
something else to happen?
So we deployed that out, and we're having some problems.
Okay, so we are waiting,
So
but
we're
we
having
need
another
to figure
outage,
out the
and
next
and
step.
yeah.
Right, and this isn't. Is this a? Is
But everything
Kubernetes
so far has
down?
been
What
great.
version are we
Like
on?
our side, the infrastructure stability
Should
has
we-
been
should
exactly
we
what
deploy
we
a service
expected. We
mesh?
can't do anything
Do you think
about
that would help?
the application layer, yes, but we're getting to that
we're not
reliability
gonna
moment.
proxy
And so,
anything.
yeah, we're having an outage right now. I just want to hit record
and where did we
just to
hear
make sure
about
that we
this?
don't miss anything else. So,
Okay, so Twitter told us, everyone, all our customers.
It's called X now.
So they know.
hey, did anyone update the status page?
Oh, I forgot. I should have done that. Oh my gosh. Why didn't we? That needs to be part of the run book.
Well, it turns out any
oh,
amount
no.
of
Okay, someone go
engineering
do that right now.
effort can't fix broken process.